Yeah, guys, thanks for joining this boot camp. Okay, today we are going to know about SSL handshake. I think who are already joined the Palo Alto course, I think they already know this how SSL handshake will happen. Okay, so this is especially for those who haven't known about what is SSL and what is what will happen in the SSL handshake. Okay, so whenever you type, okay, whenever you have browsing something on the on your web browser, okay, what will happen in the background? Okay, I actually Ramesh already explained you some process, right? For suppose whenever you are typing, okay, whenever you are browsing, let's suppose I am browsing www.tungabhadranetworks.in, okay. So what will happen in the background? First, what step, which step it is going to execute first? The first thing it will happen, it will resolve the IP address for my Tungabhadra networks, right? Whatever the website that I am going to browse, it will be resolving the IP for my DNS. Okay. After resolving the DNS, it is going with the second one. Yeah, TCP handshake will happen. Okay. Yeah. After DNS resolution, the TCP handshake will happen. Okay. Till now, you are well aware of this DNS resolution and TCP handshake, right? So after the TCP handshake, after successful connection of the TCP handshake, the data will be shared between client and server, right? So in order to securely send the data between client and the server, or in order to protect our data between client and the server, so again, one more thing will going to happen. That is an SSL handshake. Okay. Why we need SSL handshake means whatever the traffic that we are whatever the traffic receiving between the client and server, it is going via internet or via any public servers, right? So in order to protect our data, we again we need to protect our data from the attackers or from the hackers to steal our personal information, or the or our whatever the information or whatever the sensitive information that we are sending. So we need to protect our sensitive information or important information, right? So in order to protect, we need to establish an SSL, like uh, how we can make a TCP connection. We need to make an SSL connection as well. Okay, for that we are going to do an SSL handshake. Okay, this mostly between the client and the server. So like how the TCP handshake will happen, this TSSL handshake will also happen between the client and the server. So here we will be having multiple messages, okay, multiple messages. The first message will be like client hello, okay. The first message that is going to initiate, the client is going to initiate, though the first message is an client hello, okay. So what will happen in the client hello, and what is the client is going to exchange, that going to send to the server means the client will be having TLS versions, okay. Whatever the TLS versions that in order to form an SSL connection between client and the server, we'll be having multiple TLS versions, okay. What TLS version means, we have TLS 1.0, okay, TLS version 1.0. Again, we'll be having TLS version 1.1, TLS version 1.2, and recently we'll be having TLS version 1.3. Okay, these are the four TLS versions that the client is going to use. Okay, while these are the four TLS versions that client is going to support. Okay, so whatever the clients that they are initiating the connection, they will be supporting all these four TLS versions. So it will be sending, the client is going to send all these TLS versions to the server. Okay, so apart from TLS versions, it will also send the cipher suits. Okay, what what are these cipher suits means? These cipher suits contains encryption algorithms. Okay, encryption algorithms like we will be having AES, DES, 3 DES. Okay, and hashing algorithms, okay, authentication algorithms. All these combinedly called as in cipher suits here, okay. All these combinedly called as in cipher suits, okay. Whatever the cipher suits that client supports, okay. Maybe we'll be having, if it supports 16 cipher suits, it will be including that in the client hello, or otherwise if it is supporting 20 cipher suits, it is going to add in the client hello, okay. So we'll be having TLS versions, cipher suits, and apart from cipher suits, there will be a client random, okay. So what is client random instance? This is an random string that client is going to add, okay. This is a random string the client is going to add. So this will be helpful for further process in the SSL handshake, okay. I will let you know after second, third step, okay. So this is the first packet that client is going to send the client is going to send to the server, okay. What it contains, the client hello contains supported TLS versions, supported cipher suits. Along with that, we'll be having client random, and again we'll be having extensions, okay. I forgot to tell you, there are some extensions. I will show you in the packet captures, okay. I will show you in the packet captures what are those extensions, okay. So these are the things that client is going to send to the server, okay. Now the packet is ready, the client hello packet is ready, and it is going to send to the server, okay. So the server receives this client hello, and in response to that, the server is going to generate a second packet or second message, which is a server hello, okay. So what the server hello contains means, so the client sends all the TLS version, cipher suits, client random, and extension, right? So the server is going to select one of the TLS version that it supports, okay. If it is supports 1.0, it will be going to place in the server hello. If it is supporting TLS 1.1, it is going to place in the server hello, okay. For suppose the server is going to support TLS version 1.2, okay. TLS version 1.2, okay. So it is going to place here in the TLS version 1.2, and here we are sending 20 cipher suits, right? Among 20 cipher suits, the server will select one supported cipher suits, okay. If it is supports one or two or three, the server is going to place only one cipher suit that it supports, okay. So we will be having one cipher suit here, supported cipher suit. Among 20, it will select one cipher suit, okay. And apart from this, the the server also will be send server random in the server hello, okay. Apart, like client random, this is also a normal random string that is going to send from server to the client. So these are the things that the server is going to place in the server hello. So apart from this information, the server also going to send certificate along with the public key, okay. Certificate plus public key, okay. So why the server is going to send certificate and public key means, this server is located somewhere else in the internet, okay, somewhere else in the internet, okay. So in order to trust, okay, in order to trust, our clients has to trust this server, right? Because this is somewhere in the internet, and we need to authenticate first, okay. We need to authenticate whether we are receiving the information from legitimate server or not, okay. For that purpose, the server is going to send the certificate along with the public key, okay. This public key, why we use public key, I will tell you, okay. And apart from certificate and public key, it is going to send server hello done here, okay. Server hello done, okay. These are the information that server is going to include here, okay. The server is going to include here in the server hello, and it is going to send from server to the client, okay. Once this information server hello receives the client, what client will do means, client going to use certificate, and the client going to authenticate to the server using this certificate, okay. Whatever the certificate that the server sent to the client, the client will authenticate, okay. Client will authenticate to the server using the certificate, whatever the certificate that server send, that is going to use for the authentication. Okay, so why we need authentication? In order to know whether we are receiving the traffic or whether we are receiving the packets from legitimate server or not. Maybe we have I told you, right, the server will be in the internet. Maybe we are receiving the request or server hello from different servers. Okay, maybe there are some spoofing servers will be there. Maybe if we request spoofing server hello or any other request from the spoofing servers, we are not going to entertain that. We are not going to we are not going to accept that, right? Because we already authenticate with the legitimate server. Okay, so that is the purpose. This certificate will helpful here in order to authenticate the client and in order to know if we are receiving the traffic or packets from the legitimate server or not. Okay, and apart from authentication, if required, okay, if server requires client authentication, okay, mostly the server don't needs an client authentication because these clients are uh, these clients resides inside our private network, right? The servers mostly don't need an client authentication. So if server request, okay, if server requires an authentication, the client will also send an client certificate. Okay, this is not a mandatory one, but if the server requires client authentication, the client will send an client certificate for authentication. Okay, and along with the client certification, it will send an client hello done. Okay, so this where client hello and server hello will done. Okay, server hello done and client hello done. Okay, now we'll be having client random here, right? Client random, and here also server random. Okay, both client and server will be having client random and server random. So now what the client will going to do is, client is going to create some pre-shared key. Okay, so this pre-shared key will generate by the client. Okay, the client will generate, okay, by using some by using some algorithms. Okay, so the client is going to create an pre-shared key which is, okay, this pre-shared key which is that is internal to our network. Okay, internal to our network. So what the client is going to do is, the client is going to encrypt this pre-shared key using an public key shared by the server. Okay, so here the public key, whatever the public key shared by the server, the client will generate an pre-shared key using algorithms and it will be encrypting. Okay, so here the public key will be used. Okay, whenever you see the public key, this public key will be helpful to encrypt our data. Okay, so whatever the public key that are received from the server, the client will use this public key and it will be encrypt the data. Okay, because these are the some sensitive information and confidential information which is between client and the server. Okay, no one in the internet has to see this pre-shared key. Okay, so the client is going to encrypting this pre-shared key using a public key and it will send to the server. Okay, it will send to the server over the internet. And what server will do now? So the server will be having a private key along with the public key. The server will be having private key. So using this private key, this whatever the encrypted pre-shared key received, right, it is going to decrypting. Okay, and it is going to decrypting that and it will see the pre-shared key received by the received from the client. Okay, so here you have to remember the public key and private key. Okay, what are the purpose of public key and private key? Okay, public key will be helpful to encrypt the data and the private key will be helpful to decrypt the data. Okay, so the public this is a these are the keys where encryption, and these are the keys where helpful in the encryption and decryption process. Okay, just make sure remember the public and private key. Public key will be helpful for encryption and private key will be helpful for decryption. Okay, so now the client will be having client random, sorry, both are same in the sense, both are not same. Public key is different, private key is different. Public key will be sharing in the public, but private key will not be shared anywhere. Okay, it will be resides inside the server only. No, no, no. Public key only, the server will share only public key. The private key will not share because the private key won't be shared over the internet. Server only. It is generated by server only. Yeah. Now, the client will be having client random, server random, and pre-shared key, right? Both client and server will have both client, all the three, okay? Client random, server random, pre-shared key, right? So now here, the client having client random, server random, and pre-shared key as well, right? And the same thing will be having on the server as well, okay? Using all these, what client and server will going to do is client and server will going to generate and session keys, okay? the client and the client and the server going to generate, okay? The client and server are going to generate session keys using all client random, server random, and pre-shared key, okay? Here we'll be generating pre-shared key, sorry, session key, and server also will generate an session key using client random and server random and pre-shared key, right? So why they are going to generate an pre-shared key means this, why they are going to generate session keys means these session keys will be helpful to encrypt decrypt our actual application data, okay? Once these session keys are generated, our actual application data will be encrypted using these session keys, okay? So whenever, let's suppose here we have client, okay, and here we have server, right? So whenever we generate a traffic, okay, whenever we are browsing Tungabhadra networks.in here, okay? So once the server, once the client generated traffic, and once it is sending out through the public, okay, what it will do means using this session key, that traffic will be encrypted here, okay? This traffic will be encrypted here and will be sending to the server. What server will do? Server will use this session key to decrypt the data, okay? So now we'll be having common session keys on client and server in order to encrypt and decrypt the data, okay? Our actual data will be flown in the encrypted format, okay? Once the session keys are generated, and these session keys from on the client will be encrypt, and this again the same session key will be used to decrypt the data here, okay? And it will be checking www.tungabhadranetworks.in, and if we have that, the server will respond, right? The server will respond for that, whatever the request that it got. And once this the server sending that response, what it will do, it will again encrypt the data or whatever the response that server is going to send using an session keys, okay? And it will encrypt the data and it will be sending to the client again, okay? What client will do? The client will use the session key to decrypt the response that is coming from the server, okay? And now once the session keys are created, okay, between client and the server, we are forming an SSL VPN, okay? SSL VPN, okay? It will be forming secure layer. It will be forming secure layer in order to send this whatever the traffic that is flowing between client and the server through this VPN, okay? So no one in the internet will able to see what exact data that is going to send here, okay? And once the secure tunnel formed between client and the server, both will send an finish message, okay? Both will send finish and also here finish message. Just a minute, guys. Just Yeah, guys. Once I'm back. Once we form and secure tunnel SSL tunnel between client and server, the both client and server will exchange the finished message. That ends the SSL handshake. Okay. And do you have any questions or do you have any queries on this? Mhm. Yeah, using some algorithms, the client is going to generate an pre-shared key. Being sent to the server over the public, and that pre-shared key will be encrypted by the public key. Yeah. We have seen the public key here in the server role, right? Using same public key, that client is going to encrypt that pre-shared key. Now both will after exchanging pre-shared key, after sending client after client sending the pre-shared key, both will be having same pre-shared key now. Yeah. Do anyone have any questions or do you need any clarifications on the SSL handshake? Cipher suits means this is a combination of all the encryption algorithms, okay, hashing algorithms, authentication algorithms, okay, all will combinedly called as an cipher suits here. Yeah, those are the some random strings that is going to generated by the client and will shade between client and server. This is a random string, not an exactly what we can see, but this is a random string that is going to send by the client. Yeah. And the same thing, the server also will shade the random string, which we called as a server random here. Any questions, guys? Others? Yeah, in the interview perspective, they will be going to ask the SSL handshake process, okay, and also one more thing they will be going to ask is public keys and private keys, okay. What are public keys and private keys? Why they are going to use here, okay, and what is encryption and decryption as well, okay. I will tell you what is encryption and decryption, okay. So here, what is encryption means? Encryption is a process where we are going to convert our plain text into and cipher some cryptographic text. Okay, so plain text into some cryptographic text. Okay, so why means we are going to why we need encryption means so in order to not in order to secure our data. So what client is going what and client and server will be going to is they will be encrypting the data. So let's suppose I'm sending some hi I am ABC, okay. I'm sending hi I am ABC. So I'm going to send. Okay. Before going to send, I don't want to others. Okay. Who are available in the internet, they are not. I'm not willing to share this information over the public. Okay. Sharing in the sense no one want to see my message. Okay. In the public. Okay, whoever available in the public, those I don't want to see my message. Okay. So what I'm going to do is I am using an public key. Okay, and I am going to encrypt this data. Okay, so encrypting in sense it will be convert into some random, okay, like this. Okay, some special characters and we'll be having some numbers here. Okay, so I'm converting this hi I am ABC into this random special characters. So whatever the information that is go over the internet, this cryptographic text will be shared into the public. Okay, so whoever access this information, they don't know what exact it is. Okay, so by seeing this, I don't know what exact the information it is. So once this encrypted data sent by the client and this is received by the server, okay, what server will do? Server will decrypt the data. Okay, decrypt using private key. Okay, this data will be going to decrypt. Okay, decrypt, why it how it is going to decrypt it using a private key only. Okay, So what is decryption means? This is a reverse process of encryption. Okay, the cryptographic, the crypto text will again convert to plain text. Okay, this cryptographic text will be again convert to the plain text. So the server will read, hi, I am ABC. Okay, so this is how the decryption and encryption will work here. Okay, these are the one more question that they are going to ask in this. Okay, what is encryption, what is decryption, what is the purpose of public key and private key, and the SSL handshake process. Okay, and one more important question is there. One more important question. Okay, let's suppose I am giving the packet capture. Okay, I am giving the SSL packet capture. So I want to know what type of traffic it is. Okay, if I am browsing www.facebook.com or www.instagram.com, I want to know which traffic it is. Okay, so how we are going to identify means I will show you in the packet capture. Okay, so if do you have any queries or any questions on this SSL handshake or yes? Yeah, yeah. I think Sheshu. Yeah, go ahead, Sheshu. Mm. Oh no, no. Oh. Mm. Mm. In that case, the client and server will not going to negotiate. Okay, going to negotiate, and there will be no SSL handshake will be formed. So what we are going to do is, if server supports TLS 1.3, it will also support 1.1 or 1.2, so that we need to downgrade that server. Because if the server is supporting TLS 1.3, previously it is also supporting 1.1 or 1.2, right? Whatever the client is going to support, so it has to be matched on the server side as well. So what we have to do is we have to downgrade that TLS version, whatever the client is supporting. Then only client automatic, in this case the automatic process won't happen. Okay, by seeing packet capture, what client supports and what server supports we know. Okay, so the client will support suppose TLS 1.1, but server supports 1.3. So we need to manually downgrade the server TLS versions to 1.1. Yeah. See guys, we are going to take the packet capture now. Okay. So what I am going to do is I am going to browse my Tungabhadra networks.in. Okay. And before that, what I will do is I will open the Whiteshark and I will capture the packets on my local laptop. So I'm using the Wi-Fi. Okay, I'm using the Wi-Fi. So I'm going to capture the packet on my Wi-Fi adapter. Okay, all the my local laptop traffic is flowing through the Wi-Fi adapter. Okay, because I have connected to the Wi-Fi, right? So I'm going to start the packet capture on this. Okay, so it is huge traffic it is going. Okay, so now I'm going to browse www.tungabhadranetworks.in. Okay, so I got an access, right? So now what I'm going to do is I'm going to stop the packet capture. So I got my required access, right? I got my required access. So what I'm going to show here is so we need to check whether DNS resolution is happened or not, and also after DNS TCP handshake happened or not, and after that we can see the SSL handshake happened or not. Okay. See here, in order to know whether this is, we will be having huge traffic here, right? On the packet capture, we'll be having huge traffic. So in order to know whether we have a Tungabhadra network traffic or not, what we are going to do is we can going to use a filter called frame contains. Okay, frame contains double quotes Tungabhadra networks. Okay, Tungabhadra networks. So this is the one filter where you can filter only the Tungabhadra network traffic. Okay, so see here, I have I type www.tungabhadranetworks.in, and I'm filter with the Tungabhadra networks only. Okay, so here we'll be having DNS query. Okay, and do you have any? Let's go with this. Mm. Most of the traffic is not received. Yeah, see here, we have an DNS query, right? For it, we have a DNS query for www.tungabhadranetworks.in. Okay, and what we are getting is we are getting a response for the query. Okay, here we are getting a response from this query, and we got an records A record and C name record. After that, we need to we need to check the TCP handshake is happened or not. Okay, this is the response where we got. Okay, I think you have already verified the TCP packets and Whiteshark, right? So I'm going to verify only the SSL packets. Okay, after DNS and successful DNS and TCP, so I'm going to verify only the TLS. Okay, TLS packets. Here we'll be having DNS response. After that, SYN. Okay, this is SYNAC and ACK we got. Okay, and after that we need to check the SSL TLS. Okay, like TLS version 1.3 it is going to support, but here we'll be having SNI, right? So we need to verify with the Tungabhadra networks.in. Okay, we can filter only the TLS version. Okay, so apply as filter with selected. Okay, it will be filtering with the TLS version 1.3. And see here, we'll be having client hello here. Okay, client hello for www.tungabhadranetworks.in. Okay, tungabhadranetworks.in. So here this is a client hello packet. Okay, this is a client hello packet. If you open this, we'll be having handshake protocol. In the handshake protocol, see here, this is a client hello. Okay, and it is going to send a version here which is going to send 1.2, and this is a client random. Okay, and also it is going to it is going to support cipher suits. Okay, 16 cipher suits. Okay, what are the cipher suits that it is containing? So all the cipher suits. Okay, these are the cipher suits where it will be having uh, authentication. Okay, authentication algorithms, encryption algorithms, and hashing algorithms. Okay, all the 16 cipher suits it is going to support. And apart from that, we'll be having extensions as well. Okay, in the extensions, okay, I told you, right, I will give the packet capture with the whatever the packet capture I am giving. I need to verify whether which traffic it is. Okay, whether it is an facebook.com or whether it is an instagram.com or whether it is an Tungabhadra networks.in. Okay, from where you can verify means in the extension. Okay, in the extension we'll be having multiple extensions. If you see here, we'll be having multiple extensions. In these all these extensions, we'll be having one extension called server name. Okay, if you open this extension, we'll be having server name indication extension. Okay, we'll be calling as an SNI. SNI means server name indication. So you can open this. So here you can see the server name. Okay, server name www.tungabhadranetworks.in. Okay, from here you can identify the traffic. Okay, which traffic it is. Okay, so if anyone asks, if I give the packet capture SSL packet capture and I want to know which type of which traffic it is. Okay, so what you have to reply with is from the client hello. Okay, in the client hello we'll be having SNI extension. Okay, in the SNI extension you can verify the server name. Okay, server name whatever the, see here I have browser www.tungabhadranetworks.in, right? So from here you can identify this traffic belongs to tungabhadranetworks.in. Okay, from from this server name you can identify. Okay, and also this is the one major question where most of the interviewers are asking. Okay, I'm also giving I also in the recent past I have also given the interview. So they have asked me the same question. Okay, I will give the two packet captures and I want to know which packet capture belongs to facebook.com and which I want to know the packet belongs to facebook.com and I want to know this packet belongs to instagram.com. Okay, in that way they will be questioning in the interview. So if you want to know the type of traffic, okay, the which traffic it belongs to, so you can verify here. Okay, in the SNI field using the client hello and SNI field, you'll be see the server name. Okay, this is the client hello. Okay, and this is the client hello, and this will be let's what we are going to do is, yeah, just a minute. Yeah, follow the TCP stream. Yeah, this is a server hello. This is a client hello, and after that we'll be having server hello. Okay, and in the server hello, it is going to send an server hello. Okay, what are the version that it is going to support? Okay, and it is going to select only one client. Okay, one cipher suit here. Okay, see here, the server is going to select out of, in the client hello we see 16 cipher suits, right? So among those 16 cipher suits, the server is going to select only one cipher suit that it is going to support. Okay, and apart from that, here the server is going to send an public key. It will be having along with the certificate. Okay, that's what I am checking here. It has server hello, change cipher specs and application data, but we are not seeing an certificate here. The public key is along with the certificate. I think the certificate has, we have not received a certificate. We have only the server hello only. Extension, key share. Actually, this is a pre-shared key, but before the pre-shared key, that it is going to send an certificate and key exchange, but the server has not sent an certificate and key exchange here. Maybe we can check with the Facebook once. Let's I will save this. Let me verify with facebook.com. Okay, let me filter the frame. Facebook. Yeah. This is a client hello. Let me follow the stream. Okay. Client hello, server hello. Here we are not seeing any certificate here. Change cipher spec, DNS record. Stream equal to 11. Application data only will be having. Application specific. Server hello, server hello. Actually, along with the server hello, we need to have a certificate and public key, but I am not seeing any public key here along with the, sorry, I am not seeing any certificate in the server hello. Not sure why it is not happening, but let me check on the Synac Act, and this is the client hello. Like see here, we will be see along with the server hello, we'll see the certificate and the server hello done. But in our case, uh, we are not seeing any certificate. But if we have a certificate, the server will send server hello along with the certificate, and if you see the certificate will be here. Okay, so the certificate, signed certificate. So here we'll be having public key information here. Okay, public key information and the certificate. In the certificate itself, we'll be having public key information along with the certificate. But in our case, I'm not seeing any certificate. I will check and I will let you know. But see here, uh, the server hello contains all the TLS version and whatever the ciphers that it is going to support. Along with that, we can see the certificate. Okay, inside the certificate, we'll be having an public key information. Okay, so we'll be having a public key information along with the certificate, and it will be sending in server hello done. And here also it is going to client key exchange. Okay, client key exchange, and after that it is going to shade and I think we'll be having here in the key exchange cipher encrypted handshake message. to run on record. Yeah, see here we'll be having pre-master key, and we'll also called as an pre-shade key and pre-master key as well. Okay, here we'll be having in the client key exchange, and it is going to share an pre-master key. Okay, and this is an encrypted one only. Okay, you can see here encrypted handshake message, where it is going to encrypt using an public key only. Okay, public key of the server that is sent on the server hello. Okay, after that, after sharing an pre-shared key, it is going to form a new session keys, and it is the both server and client will be forming a new session keys. Okay, and after that it is exchanging the data. After this is the application data that is going to exchange over the VPN or SSL VPN that is going to happening. Okay, see here HTTP over TLS. Okay, our application data will be flowing through the HTTP over the TLS, which is an our HTTPS traffic. But in our case, I am not sure what's happening, but I haven't seen any certificate. I will check once more and I will let you know. Okay, but somehow the packet capture will look like this. Okay, in the server hello itself, we'll be having a certificate along with the public key, and client will generate an pre-shared key, and it will be exchanging in the client key exchange packet. Okay, this is how you can verify the packet. Okay, you can verify the packet capture, whether the pack if our traffic is recorded in the packet capture or not. Okay, but here in the SN I feel it is not captured anything here. This is an IP address. Okay, this is directly going with an IP address, that's why it is not captured. But if you have typing if you are using an any website or URL, it is going to capture here. Okay, do you have any questions or any queries? Yeah guys, any questions or any clarifications on this SSL handshake? I think you have got some idea about SSL, right? How the SSL handshake will happen after the TCP handshake. Okay, any questions or any queries here? Okay, others? Yeah, so far we have discussed about the SSL handshake, right? So what are the messages that is going to happen, that going to exchange in the SSL handshake? Okay, the first message will be an client hello, where it is going to send supported TLS versions and cipher suits, client random and extensions. Okay, extensions are whatever the extensions I have shown you packet capture, those all it will be sending to the server, and in response with that the server will generate an server hello with the TLS version that it supports. Okay, among all the TLS versions, it is going to select one TLS version that it supports and one cipher suits, and it will be keeping one server random, which is a random string, and along with that, it will be sharing certificate and public key, and it will also send an server hello done. And once this server hello receives the client receives the server hello, it is going to authenticate the server using a certificate. Okay, and after the authentication, if client authentication requires, okay, if server needs client authentication, the client is going to send an client certificate. Along with that, it will send an client hello done. Okay, and once this client hello sent by the client, it is going to generate an pre-shared key, and the client is going to send that pre-shared key to the server. Okay, so before going to send, it will be encrypting the pre-shared key with the public key, and it will the encrypted pre-shared key or pre-master key will be sent to the server, and the server will receive that encrypted pre-shared key, and it will be decrypting using a private key. Okay, and now both will be having pre-shared key, right? Common pre-shared key. And the client and server will have all this client random, server random, PSK, and it will be also having client random, server random, PSK. Using all these three things, the client and server will be going to generate and session keys. Okay, here one session key, and we'll be having same session key here as well. And these session keys, okay, once the session keys is formed, there will be the SSL VPN will be the SSL VPN will be formed between client and the server, where our actual application data, okay, actual application data that will be shared between our client and server using an SSL tunnel or SSL VPN. And before sending out, the client will encrypt the data using this session key. Once the encrypted data receives here, the same session key will be used by the server to decrypt the data. Okay, once the session keys are generated and once the tunnel will form, the both will be exchange the finished message. Okay, that's where our SSL handshake will done. And once the SSL handshake will done, our actual application data will be flown in a secure manner in the SSL VPN or SSL tunnel. This is the concept of SSL handshake. how how exactly, in the sense, if the server needs authentication, it will send an authentication request. Okay, and when the client receives authentication request, it will share the certificate. But most in the most cases, the servers don't ask for the client authentication. Okay, we cannot see. In the rare scenarios only we can see if really the server needs the client authentication. But in most cases we cannot see the client certificate and client authentication. Yeah. Oh yes. No, both will generate the session keys. Okay, it will not exchange it. Okay, it will not exchange. If the both client and server will uh, will generate the session keys using client random, server random, and public pre-shared key. We'll be having all this in common, right? On both client and server, using all these three things, they are going to create an session keys. It will not going to exchange anywhere. Yeah. In that case, in that case you can just go with client hello. Okay, in the client hello itself, you can identify the facebook.com URL in the server name indicator extension. Or if they ask if they ask complete SSL handshake, you can go with the all these messages. Okay, no need to mention this SNIs. Okay, you can just go with the process, and if they particularly ask that question, you can you can tell that. Okay, in the client allow will be having server name indicator, where it will be capturing or where it will be identifying the the URL or the FQDN that we are going to access. Yeah. Yeah, guys. Any other questions? Yeah. Yeah. Hi, Naveen. Yeah. Okay. Mm. మన దాంట్లో యాక్చువల్గా సర్టిఫికేట్ రాలేదు. యాక్చువల్గా మనకి ప్యాకెట్ క్యాప్చర్లో సర్టిఫికేట్ రాలేదు. సర్వర్లో నీకు సర్టిఫికేట్ కనపడుతుంది అక్కడ. యా, if you see here, we'll be having server hello and we'll be having certificate, right? Are you seeing that certificate? Actually, we have to see the certificate there. We have to see the certificate, but not sure what is going on behind. But we'll verify that. Okay. But actually, the packet capture will look like this. Okay. In the server hello itself, we'll be see the certificate, and inside the certificate, we'll be having a public key field as well. Okay. Yeah. Something maybe issue with reaching the server, or server is not sending a certificate. That I will check and I will let you know. Okay. ప్రతి సర్వర్కి సర్టిఫికేట్ ఉంటుంది ఖచ్చితంగా. ఇక్కడ మనకి క్యాప్చర్ అవ్వలేదు. యాక్చువల్ మేబీ సర్వర్ సెండ్ చేయలేదో తెలియదు కానీ ఐ హ్యావ్ టు వెరిఫై దట్. యా. సర్టిఫికేట్ దట్ డిపెండ్స్. ఓకే. ఇఫ్ దట్ డిపెండ్స్. సర్టిఫికేట్ ప్రొవైడ్ చేసే వాళ్ళు నీకు 3 months అయినా ప్రొవైడ్ చేయొచ్చు. ఎక్స్పైరీ డేట్ వ్యాలిడిటీ 3 months అయినా పెట్టొచ్చు, 6 months అయినా పెట్టొచ్చు, 1 year అయినా పెట్టొచ్చు. ఓకే. డిపెండ్స్ ఆన్ ఇఫ్ ద సర్టిఫికేట్ you have provided a certificate with validity for 3 months. Before expiring, you have to renew. Okay. uh, to not disturb our traffic, or to not disturb anything, before renewal only you can before disruption you can renew the certificate. Okay. Before the validity date. Mm. Mm. Mm-hmm. But low risk, high risk, that depends upon the URL category. Okay. That is different concept. Yeah. ఫైర్ వాల్ ఉంటే మనం డీక్రిప్ట్ చేయగలం. నువ్వేమంటున్నావు? ఎన్క్రిప్ట్ వచ్చే ట్రాఫిక్ మనం డీక్రిప్ట్ చేయగలం అంటున్నావా? అవునవునవును. ఉమ్, 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 ఉమ్. యాక్సెస్ అవుతుంది. ఇప్పుడు మనకి అక్కడ మనకి పబ్లిక్ కీస్, ప్రైవేట్ కీస్ మన దగ్గర ఉన్నాయంటే మనం యాక్సెస్ చేసుకోవచ్చు. ఇప్పుడు మనకి సర్వర్ పబ్లిక్ కీ ఉందంటే మనం ఎన్క్రిప్ట్ చేయగలం. ఓకే. మనం డిక్రిప్ట్ చేయాలంటే సేమ్ ప్రైవేట్ కీ మన దగ్గర ఉండాలి. ఎన్క్రిప్ట్ అయితే చేయగలం. డిక్రిప్ట్ మనం చేయలేం, ఎందుకంటే మన దగ్గర అంటే ఐ మీన్ సేమ్ ప్రైవేట్ కీ ఉండాలి. ఉమ్, ఉమ్. చేస్తాయి. యా. ఇక్కడ మనము ఎన్క్రిప్షన్ డిక్రిప్షన్ చేయాలంటే ఓన్లీ డిపెండ్స్ ఆన్ ద పబ్లిక్ అండ్ ప్రైవేట్ కీస్ ఓన్లీ అండి. సో ఇఫ్ యూ హ్యావ్ సేమ్ పబ్లిక్ అండ్ ప్రైవేట్ కీస్ వీ కెన్ డూ డిక్రిప్షన్ అండ్ ఎన్క్రిప్షన్. మనకి సేమ్ మనకి పబ్లిక్ కీ అయితే మనం తెచ్చుకోగలం. ఓకే. సర్వర్ ఒక పబ్లిక్ కీ అయితే మనం తెచ్చుకోగలం. సో వీ కెన్ ఎన్క్రిప్ట్, బట్ we cannot decrypt. Okay. Because the private key will be not having the same private key, right? So we cannot decrypt the traffic whatever the we are receiving if we are in between. Yeah, guys, any questions? Okay, guys, if you don't have any questions, we can wind up this session here. Okay, we'll be sharing the recording video after this class. Okay, we'll after half an hour or 1 hour, I will share the recording video. So you can go through once again, and if you still have any questions, you can just reach out to me. We'll discuss on that. Okay. Thanks, guys. Thanks for joining. Have a good day. Bye.